Eiji Onchi. I'm a student of mechatronics engineering at Pontifical University Catholic of Peru, South America, and a member of MDRS Crew 126 Team Peru, and co-founder of the Mars Society Peru chapter in Peru. Let me give you an insight of the project we did while we were there in March. So the first question is, what is DAM? DAM stands for Data Acquisition Modules, which are small boxes that can gather climatological data, and then it communicates through a small flexible network to a main server. The code name of this project was Barsu, as a Edgar Rice representation of Mars. And the main objective of this Barsun project was to test a deployable network that would be of use for early expeditions to the red planet. It will work like a micro GPS without the satellites. This system is capable of collecting data, allowing communication between crew members, and roughly locating an astronaut's position, and being portable. So let's see a little bit about the communication network. This system is composed by a master device, which controls all the communications. And we add a little slave device, which are the small boxes, which will collect data and will act as repeaters. So these repeaters are connected through radio signal frequencies and can create many kinds of paths. So, if we want, for example, to communicate with that specific device, and the main server computes the shortest path and then sends the signal. The slave device captures that signal and starts fetching the data, and it will send back the data through the same path the main server did. So you could get any weather data outside the main hub. So let's see what happens when you want to get the same communication, but one of the devices is broken. So the main server detects this anomaly and tries to create another path to reach the target. So you can have many ways of reaching from point A to point B to get the data. And how does this main server knows that you have lost connection? Every time you send a signal, it's expecting to receive an acknowledge. So if there's no acknowledge, it assumes that the device is broken and it starts creating another path. Okay, now let's see the other function of this little network, which is location range. Imagine you have a crew member outside in an EVA mission, and it's located over there. So these two devices will detect the signal each crew member is sending through a gadget, and the main server will compute a possible location for that crew member. So this is really useful for when you want to track a crew member position without a GPS, because when you go to Mars, there won't be any satellites before any humans reach. So for an early expedition, this will be like a great location system. And what happens if the crew member is in danger? The device in the crew member will send a danger signal, an alert, that will notify the main server, and the search and rescue team can get there because they know the potential location of the crew member. We can minimize the zone, adding more and more slave modules to have a more efficient zone over there. So how does this system communicates with each other? Each module receives the signal through a package. This package is made of three parts: a root, a body, and an outro. So the route is the path the main server calculates to get from point A to point B. And the body can be of any length, will be any data the slave devices capture. And the outro will be the return path that the slave will follow to get from his point to the main server. For the electronics of these devices, we have three main devices: the master device, the slave device, and the portable gadget. So the master device is the main server. It's a computer which a transceiver that is connected via USB and collects all the data, processes and output information that is useful for the mission. Also, we have the slave device, which also have a transceiver, weather sensors, a microcontroller, and batteries. Because we were not focusing on energy, we just used AA batteries, but if we are going to take energy power, it would be solar power. And the portable gadget, this gadget will be attached to the crew member, so this can send the distress signal, communicate with the main server, and also have a battery of its own. The microcontroller we used for these missions were the Atmega 8, which are pretty common in Peru. To create each device, we try to use our local resources. Electronics is not that easy to get in our country, so we use really basic structures like radio frequencies, modules, and atmels. So overall cost was like $20 per slave device. And then we went to MDRS to test our system. We placed several slave devices outside the station to test our network, but it never goes as expected. Our radio frequency, which was 433 megahertz, was jammed by the static noise of the desert, so we couldn't get any communication at all. The antennas didn't work, so we changed it from radio frequency to Bluetooth to establish the communication. The Bluetooth has a shorter range, which was like 50 meters radius, but it allows us to test our network, which was the main objective of this project. So the Bluetooth made the communication possible and proved that this kind of network works in desert-like environment. So for the future, we would like to put these slave devices onto like jumping robots, which can be deployed without any aid of a human being. You can just leave it outside the hub, and then by the computer you can just deploy the network. You wouldn't need to be physically there to establish a relatively great big network. And you don't need to go on extended EVAs to place those repeaters outside. Also, we're planning to adapt this network to use Wi-Fi and communicate with robots, such as rovers and quadcopters. So any crew member outside on an EVA can communicate with the main server and also control robots in the zone to go to hard-to-get areas. We will try to implement this with a suit and Google Glasses, which will establish the communication, and we're planning to make the suit more user-friendly so that the astronaut can communicate via voice to the main server and to the robots, and can keep track of their heartbeat, radio signals, and everything. Every communication will be through a visual display. So this is a project we did there. I hope you enjoyed it, and any questions, welcome. Thank you. So this spacesuit project we're planning to do resembles much of what Ken was trying to propose as a project. So I think we can integrate that to that kind of project and use the network to work with that spacesuit. We can establish like a pretty good network for NDRS to do research there. Thank you.
Real quick, you're going to have to, at some point, if you use Google Glass, separate the functions that depend on the internet from the functions that you can directly have internet.
Yes, so we're planning to integrate actually Microsoft has its own standalone voice recognition software, so it doesn't use the internet to analyze the voice. So you can just record your voice and send it over to this network and process it on the main server, and then have the function you require. So yeah, we were trying to make this also open source, so many developing groups can contribute to this project, like faster processing programs or apps that can be useful outside in space. For example, you can look at a star and it will give you the information that with an app. So we are not trying to be internet dependable, because Google Glasses is really dependable on internet for that kind of process.
But when you're saying that you would like to integrate with the internet or whatever devices, it means that you are going to put the IP communication layer on top of your protocol, or what? So it means that
on Mars, I'm sure we cannot use internet as we use it on Earth. So we will just use the Wi-Fi connection to send data, and all data will be processed on the main server, because you cannot carry like a really big computer when you go outside. So you can let the main server do all the hard processing, just send the data, the raw data, like a voice or any analytical data or weather you gather, up to the main server, and then you can do the processing. It could be a Linux.
But still, suppose I want to plug in again internet device, and then I would like to use your communication network to again plug in something like Wi-Fi was available. So can at this point use your network as Wi-Fi?
At this point, no, because our network was developed with radio frequency signals. So it didn't use Wi-Fi but Bluetooth. But yeah, you can use the same IP address to connect several devices on a small network. Any other questions? Okay, thank you.